Good morning, everyone. My name is Sumit Kumar Sahu. Now, we are going to discuss about a new chapter of class 12 physics, that is the electrostatics. So, electrostatics. Electrostatics. So, before going to discuss about electrostatics, so first we have to know what is the meaning of electrostatics. So, the simple things of the meaning of static means rest, and for electro, it means electric charge. Electric charge. So, the meaning of electrostatics is the electric charges at rest. So, in this chapter, we are going to discuss about electric charges at rest. When the charge is at rest, what is the effect? What is the effect of electric field? What is the effect of electric potential? In this chapter, we are going to discuss. So, here is a word that is the meaning charge. So, what is the meaning of a charge? Charge a body. So, this is an atom. And inside the atom, a nucleus is present. So, this is atom. This is nucleus. And inside the nucleus, proton and neutron is present. Proton and neutron is present. And outside the nucleus, the electron is revolved in their specific path. From Bohr's atomic model, you already know that. The charge of a proton is positive. Charge of a electron is negative, and charge of a neutron is neutral. So, the atom is electrically neutral because it contains same number of proton and electron. Actually, the atom is electrically neutral because atom is made up of proton, electron, neutral, and subatomic particle. Just like the nucleus is made of pi meson and other particles. So, in our just 12th syllabus, we have to discuss about atom and nucleus. And in this specific electrostatics, we have to discuss about charge. So, first thing is charge is of two types. One is a positive charge, another is a negative charge. Positive charge means the proton which is present inside the nucleus, the charge of a proton is positive. And the electron which is revolved around the nucleus in their specific path, the charge of electron is negative. And the charge of neutron is neutral. Neutron has no charge. So, atom contains same number of proton and electron. We already know the table: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, just like this. Let's say one example: hydrogen, then helium, lithium. The atomic number of hydrogen is 1, atomic number of helium is 2, atomic number of lithium is 3. So, what is the meaning of 1, 2, 3? Why? Because 1, the atomic number of a hydrogen atom is 1. Here, hydrogen contains 1 proton and 1 electron. Similarly, helium contains 2 proton, 2 electron. And lithium contain 3 proton, 3 electron. As the charge of a proton is positive and charge of electron is negative, both are cancel out each other. Hence, the hydrogen atom is neutral. It has no charge. So, how a body became charged? Now we have to discuss how a body became charged. What is the process of a charge? What are the properties of electric charge? Now we have to discuss. So, first thing is in this chapter we have to discuss the electric charges at rest. Now, charge is of two type. Charge is of two types. First is positive charge. Second is negative charge. Positive charge means the charge of a proton is positive, which is present inside the nucleus, and the charge of electron is negative, which is revolve around the nucleus in their specific path. Then an atom is electrically neutral. An atom is electrically neutral. It means atom contain same number of proton, equal to atom contain equal number of proton and a electron. Neutral. Atom has no charge. So how a body became charged? A body or atom became charged by gaining or by losing some electron. Here a word by gaining or losing some electron, not gaining or losing some proton. Because if this is an atom, here is the nucleus and the proton is present inside the nucleus and electron is present outside the nucleus. So it is very difficult for us to remove the proton because proton is bound inside the nucleus. But electron is not bound inside the nucleus. Electron just revolve around the nucleus. That's why it is very easy for us to remove the electron from this atom. Clear? So a body or atom became charged by gaining or by losing some electron. Or an atom became charged by gaining or losing some electron. Next point is, so here is the question is arises. What is the charge of what is the charge of Earth? The charge of Earth is electrically neutral. The total charge of Earth is 0. So these are the few things about charge. Now we are going to discuss more about the electric charges. Before a few minutes we discussed a body is electrically neutral and a body became charged by gaining or by losing some electron. So how could we found a body become positive charge or a body become negative charge? Here electron is electrically neutral and a proton is a positive charge. Sorry, electron is the negative charge, proton is the positive charge, neutron is electrically neutral. As electron is negatively charged, if an electron is removed out from an atom, then suppose here is the atom, here is the nucleus, here is electron, and same number of proton is present inside the nucleus. If this electron is removed out from this atom, then what happens? Suppose in this atom 2 electron is present. As 2 electron is present in that atom, 2 protons should be present because suppose this is helium atom. If 1 electron is comes out from the atom, then only 1 electron is present inside this atom, and 2 proton is present inside the nucleus. As 1 electron is present inside the atom and 2 proton is present inside the nucleus, then 1 electron cancel the effect of 1 proton. 1 electron cancel the effect of 1 proton. But 1 proton is now remains. 2 प्रोटॉन था, 1 इलेक्ट्रॉन था, 1 इलेक्ट्रॉन ने 1 प्रोटॉन को कैंसिल किया इफेक्ट को. अब कितना प्रोटॉन बचा? 1 प्रोटॉन यहाँ पे. तो प्रोटॉन का चार्ज क्या है? पॉजिटिव. As the charge of a proton is positive, that's why this atom is positive in charge. Positive in charge. Similarly, if here is the atom, here is the 2 electron is there, and this is a 2 proton. Clear? And the atom is electrical now neutral. If it is very difficult to add 1 electron inside inside an atom, but if we add 1 electron inside this, then it is very difficult. It's very difficult, and this is not easy to enter an electron inside the atom. Just suppose, so now this atom contains 3 electron and it has 2 proton. 2 proton can cancel the effect of 2 electron. 2 electron. 2 electron. 1 now 1 electron is at now 1 electron is 3. That's why this atom is negatively. This atom is negative in charge. This is just example how an atom became charged, positive or negative. The conclusion is if our body or atom losing some electron, it became positive. If it gains some electron, it became negative. Again, if lose some electron, it became positive. If it gains some electron, then it became negative. Clear? So here you have to write, especially these things comes to not to atom, these things comes to a body. So we have to write a body became positive charge by gaining some electron, and a body became negative charge by losing some electron. Losing some electron. So now we have to discuss what is the charge of an electron. The charge of an electron is 1.6 into 10 to the power minus 19 coulomb. This is magnitude. This is the magnitude. The charge of a proton is 1.6 into 10 to the power minus 19 coulomb. The charge of a neutron is 0. Magnitude. This is magnitude. Magnitude 0. And what about the mass? The mass of electron is mass. Mass of electron is 9.1 into 10 to the power minus 31 kg. Mass of proton is mass 1.66 into 10 to the power minus 27 kg. Mass of neutron is 1.67 into 10 to the power minus 27 kg. This is the charge and this is the mass of an electron, proton and a neutron. Next thing, if we apply charge on a body, if the body is symmetric in shape, if we apply charge on a body, if the body is symmetric in shape, symmetric means it has symmetry. For example, just like a football, this is spherical symmetry. Just like a cylinder, this is also symmetry, cylindrical symmetry. If we apply some charge in a symmetrical body, the charge is equally distributed everywhere. But if we give some charge to unsymmetrical body, then the charge is distributed unsymmetrically. So you have to write the charge is distributed symmetrically in a symmetrically body. For example, suppose here is a sphere. This is a sphere. If we apply some charge to this sphere, this may be positive or negative charge. The charge is equally distributed everywhere. The charge is equally distributed everywhere. But if the body is not symmetry in shape, if the body is not symmetry, then the charge density is more, the charge density is more higher the radius of a curvature is minimum, where the radius of a curvature is minimum. So if the body is not symmetry in shape, then the charge density is more where the radius of a curvature is minimum. What does it mean? Suppose a body is just like this. This is not a symmetry body. This is unsymmetry body. If we apply charge to this body, let's say this suppose positive charge, then the positive charge not distributed equally. The charge density is more where the radius of a curvature is minimum. Here the radius of a curvature is this much. Here the radius of curvature is this. So the charges are leakage at the sharp point. Clear? So these are the things, small things about charge. Another point is there. Like charge attract and unlike charge repel each other. It means, what is the meaning of like charge? Like charge means same charge. Positive, negative. These are like charge. They repel each other. But unlike charge, positive charge, negative charge, attractive. The force here comes. The force between two positive charges or the force between two negative charge is repulsive force. The force between one positive and one negative charge is the attractive force. And in Coulomb's law, next class, we have to discuss what is the force between two charges. What is the force between two charges? So now these are the small things about charge. Now we are going to discuss about properties of electric charge. So I hope it's clear.